So in this class we are going to discuss about what a system call is. So we know what is a function call. Usually functions are written in order to ease our task, and when we make a call to that function, wherever we need to execute that set of code, we can have that particular code in a particular place in our program by calling, just making a call to that function. So similar to that, in operating system we are using system calls. So system calls, they provide an interface between a running program and the operating system. So here a running program, it tells us about the application programs that we are running in the user mode. So before entering into or knowing about what is a system call, there are two different modes in memory. One is the user mode and the other one is the kernel mode. So in kernel mode, it is a mode in which the intense operations of the operating system or the main core part, where the hardware main memory, that is a memory, the hardware resources, everything it retains. So usually it is known as a privileged mode, that is it is a too intense mode, and we as a user, we are supposed to operate or execute the programs only in the user mode. Because if suppose if there is any error in our program in which we run, if there is any problem, if we are executing that application in the user mode, we will be in a safer side, because we can easily halt the program and we can change or modify the errors whichever present in that application. So it won't create any harm to the system. Whereas in kernel mode, if we do that same execution when the system is in the kernel mode, then the entire system will crash or it will halt. So it is of um, it creates more problems. It is not a safer part of operating a system, that is operating it in a kernel mode. So usually as users, we will be executing our applications only in the user mode. But during this type of execution, we are in need of different types of resources for getting the things done. So for that purpose, so as while running that application programs, we are in need of certain resources, as we have seen. In that case, definitely we need to switch from this user mode to the kernel mode, and this type of switching, it is called as context switching. Okay, so this is called as context switching. Always when a program, it switches from the user mode to the kernel mode, and also from the kernel mode to the user mode, vice versa, in both the times switching happens. So such type of switching is called as context switching. So please listen to this diagram. So first, the user process is getting executed in the user mode. So it is in no way a user process can execute in the kernel mode. It has to execute only in the user mode. But during that time, this process, it may need some of the resources, for example IO device or any memory related resources, anything it may in need of. So at that time, it cannot directly access those resources. So during that time, it has to execute a system call, that is it has to make a call, that is nothing but the system call. So it can also be interpreted as an interrupt. It can be and the name of a system call is known as an interrupt or a trap. So when this system call is made, automatically from the user mode, the particular process, it will be switched to from the user mode to the kernel mode. So this type of switching is called as context switching. So the system calls are created in this user mode, and when there is a switching happens from the user mode to the kernel mode, the system, after the system calls are being created, they get executed in the kernel mode. So creation of the system call happens in the user mode, and the execution happens in the kernel mode. So once after the system calls are getting executed in the kernel mode, once again after getting the access to the hardware resources and the memory, after getting all the things done, the system call, it will, after the process which is getting its resources used, such process is now shifted from the kernel mode to again to the user mode. So there is a return from the system call, and again the process will be returned to the user mode, and it further continues its execution here. So this is the process, this is the procedure how the system call is made between the user mode and the kernel mode, and how the context switching happens. So this is how the programs are getting executed in a safer side, that is in a more safer procedure. We are executing our applications, and we are completing the task. Okay, so there are different types of system calls. There are different many types of system calls are available. One such system calls, they are grouped into different categories, nearly 5 categories: process management, file management. The numbering is wrong here. The next is IO device management, information maintenance, and inter-process communication. So before getting into one each type, let's see the different format in which we can make these calls. That is, in Windows operating system, these system calls are named as shown here, and in Linux or Unix operating system, it is shown in this way. So process control system calls, so the name itself indicates that just for creating and terminating or making the process wait. So we know there are different types of different stages in which a process can make its execution. So for each and every stage we are having a separate system call. So for creating a process, terminating a process, making the process wait, or if suppose any error occurs in an application program or execution, in order to abort the process at a particular instance of time. So in all these task or taken care by the process management system calls. And coming to the file management system calls, everything we save, or everything we, after completion of a task, we store everything in the form of files only, or in the form of subdirectories. So in that case we need to manage those files. So for that purpose we have these type of system calls for creation of a file, deletion, opening a file, closing a file, and reading a file, writing a file, and the status information about a file, to get and to link a file from a directory, or to remove it, and to set and get the attributes of a file. For all these purposes we are in need of this file management system calls. And then coming to the IO device management, so we are about to use the hardware and the other resources available in the kernel mode, right? So the devices, input output devices, are also matters here. So at that time we need for requesting a device, and for making a device attached to our process, to get the device status information, to read and write from the device. So for that purpose these type of system calls are used. One best example for this IO device management is the use of our pen drive. So usually we may either logically or physically connect that pen drive. Physically connecting a pen drive is just inserting a pen drive into the CPU, but logically connected, even if we eject the pen drive, that is before ejecting the pen drive away physically, we can just terminate the process. So all these types of processes are taken care by the IO device management system calls. And information maintenance, this is completely related to the system data, that is setting and getting the time and date of the system, and the total storage space available, whatever the informations we are storing in that system, every the capacity, the total capacity available, or the existing space that is available in the system, all these sort of informations are taken care by the information maintenance system call. And inter-process communication, for creating a message and for closing the connection. For example, if you want to communicate with the other softwares, other application softwares, if one application software it is trying to connect with some other application software, so in that case, for sending and receiving a message, we need to create a communication link. So for such type of communications between the processes, between the applications, we are in need of this inter-process communication system calls. So these are the different types of system calls available in every system. So what are system programs? So system programs, they provide the environment for the program development and execution. So in before understanding this, we can just recollect that diagram that we have seen while discussing what is OS. So usually the lower end is we have seen application programs are running in the upper layer, and then comes the kernel, that is the user programs, and then comes the user interface, and then comes the kernel, and below the kernel or the hardware resources or the memory and the other resources available. There should be an interface between this user and the kernel process, that is the kernel of the, that is kernel where the system programs reside, because system programs and application programs may exist in that space, right? So the user programs, they can communicate, the user can communicate, they should create an user there should be a user interface, only then they can communicate with that kernel, right? That is where the system calls prevail, that is what we have seen. So those system calls, they need a platform to get executed, and those are called the system programs. So they can be divided into these five six categories: status information, file management, file modification, programming language support, program loading and execution, and communication. So status information in the sense, the some, for example, we have seen the information about the time, the date, and the total amount of space available in the system, or the disk, and how many users have logged in for a particular amount of time, or who are all currently available in the connected to the system. So such type of information can be known from the status information. And when we go for file management, as we have seen earlier, for creation and deletion, and for copying content from one file to another, and for renaming a file, so all these types of processes are carried out by the file management system programs. And file modification, so here this file management, it talks about opening and closing of a file, creating and deleting of a file. But this file modification, it talks about whatever contents are present in the file, modifying those contents. So there may be several text editors, so for creating those and modifying the contents which are stored on the disk, so in that case we need to go for file modification system programs. And then comes programming language. Say we here we use many types of languages. We code in high level languages, usually C, C++, Java, and other many more languages have come now. So at that time the system must interrupt with these languages, so there must be perfect compilers, assemblers, and interpreters. So these types of system programs comes under this category, programming language support, right? So program loading and execution, so even though the compilers, assemblers, and interpreters are available, these system programs, programming language support system programs, their task is to compile, or they convert from a high level language to a lower level language, that is system supporting language. So that type of support can only be given by the program language support. But anyway, it has to be loaded from the secondary memory and to the main memory for getting executed. So that, for that part, definitely we are in need of linkers and loaders. So for loaders are responsible for loading that from the secondary memory to the primary memory, and getting things that is getting the program executed, only then it will become a process. So after that, it also needs to link certain types of library files which are already available, and it is required by the program. So at that time you are in need of program loading and execution system programs. So these such types of programs comes under this category, system programs comes under program loading and execution category. And then communication, so these programs are necessary for creating a virtual connection among the processes. This is what we have seen, because from one browser to another browser, we need to send emails, or we need to browse contents to remotely log into that system. So at that time we are in need of establishing a virtual pipe connection. So only then the communication can be done at the at both the ends. So this type of system programs, it comes under this category, communication category. So these are the different six types of system programs available in order to get the process, access the kernel available services, so that it can run in a very safer way. So this is the end of system calls. So in the next class we can discuss about some other, the next topic. Thank you.